In this video, we'll be talking about how to predict the product of a chemical reaction. This is an important skill for anyone studying chemistry or working in related fields. To predict the product of a chemical reaction, there are a few things you need to know. First, you need to know the reactants involved. For example, let's say we have two hydrogen reacting with oxygen. Now, the product will be water, of course. And now what this tells us is that we have 2 moles of, what this equation tells us is that 2 molecules of hydrogen gas react with 1 molecule of oxygen gas to form what? 2 molecules of water. So that's what this equation tells us about. Now, in order to predict the product of a chemical reaction, you need to know the types of reaction that are occurring. There are several types of reaction, including synthesis, decomposition reaction, single replacement reaction, double replacement reaction, combustion reaction. And also, in addition to knowing the type of reaction, you also need to know the reactivity series of elements. Metals like potassium, sodium are highly reactive and will displace less reactive metals from their compounds. So let's look at some examples. When you have methane reacting with O2, how do you predict the product of this particular reaction? First and foremost, whenever you see hydrocarbons reacting with O2, what that tells you is that this is a combustion reaction. Now, for a combustion reaction, we know that the product of a combustion reaction is always CO2 and water. Sorry, these two is not supposed to be here for now. You need to put it only when you are balancing the equation. All right. Now, but when you want to, after writing it like this, after putting down the solution like this, then you go ahead and do the balancing. Now, to balance this particular equation, we know that we have 1 carbon and we have 1 carbon. So carbon is balanced. For hydrogen, this 2 that is here is supposed not to be here at first. I just went ahead to write it because I know it's going to be there, but for the sake of the lesson, it's supposed not to be there first. So we have 4 hydrogen here. To balance the hydrogen, we'll add another 2 here, which is the one that is here. Now for oxygen, we have 4 oxygen this side. Now to balance the equation, we'll add another 2 here. So now the equation is balanced, right? Let's say we have another compound. We have ethanol. We have ethanol reacting with oxygen. Now, this also is a combustion reaction. And like we said earlier, for combustion reaction, it's always CO2 and water. CO2 and water. So now, you can go ahead and do the balancing of this particular equation also. Now, what about when we have zinc reacting with oxygen? What will be the product of this reaction? Now, first thing I want you to note here is that this is addition of elements. Now, when you have this kind of chemical reaction, how do you predict the product of this reaction? Zinc reacting with oxygen. Now, when you have this kind of reaction, how you go about it is this: you put down zinc. Zinc has a +2 charge, and then you put down oxygen, and now oxygen has a -2 charge. Now, to know about the charges, we have a little chart here. Now, from this chart, you should understand that each element is a sketch of the periodic table. You see, these are These are group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8, right? Or group 18. You can say 13, 14, 15, 16, 17, 18, right? Now, group 1 elements all have +1 charge. Group 2 elements have +2 charge. Group 3 elements, they all have +3 charge. Group 4 elements have +4 charge or +2 charge. Group 5 elements have -3 charge. Group 6 elements have -2 charge. Group 7 elements, which are the halogens, they have -1 charge. And then group 8 are the noble gases, they have 0 charge, right? So now, oxygen is in group 6. Therefore, it has -2 charge. That is where this -2 comes. Zinc is in the transition metal, and zinc is having a +2 charge. And that is why we have the +2 charge here. So now, one thing again you should note is that whenever you see both elements carrying the same charge, even if the signs are opposing each other, you put them in a 1-to-1 ratio. So therefore, you are going to put zinc, and then you put what? Oxygen, right? 1-to-1 ratio. So you just put 2 here so that you can balance it. Then you add 2 this side. Now the equation is balanced. So let's take another example. This time will be a bit faster. If we have magnesium and then reacting with nitrogen, what is the product of this reaction, right? Now we have magnesium reacting with nitrogen. Magnesium is in group 2, and then it has what? 2 + 2 charge. So we put magnesium. It has a +2 charge. Nitrogen is in group what? Nitrogen is in group 5, and it has a -3 charge. So nitrogen will have what? A -3 charge. Therefore, so now you are going to put magnesium 3, and then nitrogen, you put what? 1. Sorry, you put 2. You're bringing their charges down. Therefore, what you have now is going to be what? And mind you, whenever you are writing it, make sure the positive, the cation, is written first before the anion. So you put magnesium 3, nitrogen 2, right? Now when you check, is it balanced? If it's not balanced, you add 3 here to balance it. So I think you can see it clearly. Let me just go over the explanation, because I discovered the thing was not showing properly. So you see, we see magnesium, like we said earlier, is in group 2. That's why we had this +2. Nitrogen is in group 5. That's why we have in group 5 we have what? -3. So you cross multiply, you bring down their charges in a cross from the way you see it here. So now magnesium 3 and then nitrogen 2. So you put it here. So then you balance the charges, and when you are balancing, you just add 3 here, and the charges is balanced. So if, for instance, we have sodium reacting with sulfur, right? Sulfur. Now, how do we predict the product of this compound? To predict the product of this compound, we know that sodium is in group 1. Right? It's in group 1, so it has what? +1 charge. Sulfur is in group 6. It has what? -2 charge. So now you say sodium 2 and then sulfur 1. So you put sodium 2, sulfur 1. So you just leave it like that. Now, to balance this equation, you know that we have 8 sulfur in this side, so you put 8 here. So we now have 8 sulfur this side and 8 sulfur the other side. But now we now have 16 sodium, so you add 16 here. The equation is now balanced. Next, I want us to look at this particular equation. If you have calcium carbonate, right, solid, if it's heated what will be the product? Now, whenever a metal carbonate is heated, volatile component will escape, and this volatile component is known as what? Carbon dioxide. So what will be left behind will be the metal oxide. So in this case, calcium is a metal, and now that it is heated, we say that what? Volatile component will escape, and the volatile component is what? CO2. Then what will be left will be metal oxide, which is going to be what? In this case, we have calcium oxide, right? This will still be solid, and this that escape is in gaseous form, right? Next, let's say we have magnesium carbonate. Now, if we heat magnesium carbonate, what we'll have first, what will escape will be CO2. CO2 gas will escape, leaving behind magnesium oxide. Now, the reverse of these two equations is what? Some sort of a synthesis, though in this kind it's a bit different from other synthesis, given that this one is a combination of what? Compounds, not just elements. So let's say we have CO2 gas reacting with calcium oxide. What you're going to get is what? Calcium carbonate. Now, if we have magnesium oxide reacting with CO2, what you are going to have is going to be magnesium carbonate. Let's look at some single replacement reaction. Let's say we have iron solid reacting with copper chloride. Now, how this is an aqueous form, and this I have two, there's two here, and this is aqueous. Now, how can we predict the product of this reaction? To predict the product of this reaction, we know that copper and iron, both of them are what? Transition metals. So iron will replace copper, and it will react with chlorine. So therefore, we have iron, we have chlorine. Iron is what? +2. Chlorine is -1. So therefore, we have iron 1, and then we have chlorine 2. Therefore, we have what? So this is a single replacement reaction, and then you have what? Copper metal, and this time is in a solid phase. Let's take another example. Let's say we have aluminium reacting with nickel chloride. How do you predict the product of this reaction? Now, to predict the product of this reaction, we know aluminium has a +3 charge. Chlorine has a -1 charge. So you cross them. Aluminium will now have 1, and then chlorine will have what? A 3 subscript. So therefore, we have aluminium and then chlorine. Then we have what? Plus nickel solid. Right? This is in aqueous form. This also is in aqueous form. Let's take another one. Why I'm not balancing is because we want to just go ahead and know how to predict it. That is our main focus. So we have zinc solid reacting with HCl. Now, how do you predict the product of this reaction? To do that, we put zinc. Zinc has a +2 charge, and then chlorine has a -1 charge. So you cross them, you cross their charge. Therefore, zinc 1, chlorine 2. Therefore, you're going to now say zinc chloride, right? Then you put what? Plus hydrogen gas. This is in aqueous form. Let's take another example. Let's say we have iron reacting with copper sulfate. Right? How can you predict the product of this compound? Now, to predict the product of this compound, we are going to say iron, we know it has what? A +2 charge. Sulfate, because iron is displacing copper, sulfate has a -2 charge. Now, because the charges are the same, irrespective of the difference in their sign, we are going to put what? 1-to-1 ratio. So we'll put iron sulfate. Then we'll have what? Plus copper solid. Copper is in solid form, right? So that's it. Let's take another question. Let's say we have chlorine reacting with sodium bromide. How do you predict the product of this particular reaction? Now, the product of this reaction, chlorine will react with sodium and it will displace bromine, right? So we have sodium. Sodium has a +1 charge. Chlorine has a -1 charge. Therefore, because both of them carry just the same charge, we'll put them on a 1-to-1 ratio. So it's going to just be sodium chlorine. So it's going to be sodium chloride, right? So you check if the charges are balanced, and in this case they are not. So you add 2 here, right? And then you put bromine here, plus bromine. So you add 2 here. Let's take an example of a double displacement reaction. So for double displacement reaction, let's say we have silver nitrate, right, in aqueous form, reacting with magnesium chloride. Now, how do you predict the product of this reaction? Now, to predict the product of this reaction, first and foremost, we know that silver will react with chlorine, while magnesium will react with nitrite, right? So silver has a +1 charge and chlorine has a -1 charge. So you see, both of them, the charge is 1-1. So it's just going to be what? You put it on the 1-to-1 ratio. So it's going to be silver chloride. Now, for magnesium, has a +2 charge, while nitrite has a -1 charge. Therefore, you are going to still cross them. So you put magnesium. In a case where you have a diatomic atom, parenthesis is used. So in this case, we'll put nitrite and then these two we'll put it here. So therefore what we'll have now is going to be silver chloride plus magnesium nitride. Right? So this is the product of this reaction. So you check if they are not balanced, you go ahead and balance it. So let's take another example. Let's say we have aluminium chloride reacting with sodium sulfate. How do you predict the product of this reaction? This is also a double displacement reaction, double replacement reaction. Now for this case, we have aluminium is a metal, right? Sodium is also a metal. So aluminium will be reacting with what? Sulfate. While sodium will be reacting with what? Chlorine. Now for aluminium we know it's +3, the charge, while sulfate is -2. So therefore what we now have will be what? Aluminium 2, sulfate, put it in parentheses because it's a diatomic atom. Is diatomic. So you put now what? 3. Then for sodium is what? +1, and chlorine is -1. Therefore you still what? Put it at a 1:1 ratio. Sodium chloride. So therefore these are product. Our product is going to be what? Aluminium this is supposed to be 4 here. Then plus sodium chloride. So these are products. So you check if it's balanced. If it's not balanced, you go ahead and balance it. So let's take another example. Let's say we have tetrasulfate 4 acid now it's reacting with potassium hydroxide. Now what is the product of this reaction? Now we know that for this particular reaction, we know hydrogen will react with what? Hydroxide, and potassium will react with what? Sulfate, right? Now for potassium, we have potassium has a +1 and sulfate has a -2. Therefore we have for hydrogen is +1, hydroxide is -1. Therefore you put it at a 1:1 ratio. Now therefore you are going to say this is going to be the product. So this is the product of this particular compound. Let's take another example. Let's say we have sodium carbonate reacting with HCl, right? How do we predict the product of this reaction? Now to predict the product of this reaction, still go by our process. Sodium will react with chlorine and hydrogen will react with carbonate. So sodium has a +1, chlorine has -1. So if you cross them, you still have the same thing. So you put it on a 1:1 ratio because what? Their charges are the same. So you put what? Sodium chloride. Then carbonate has a -2, hydrogen has a +1. Therefore we have what? Carbonate and then we have hydrogen because you are crossing them, right? Therefore, let me rewrite it here. We have sodium carbonate plus HCl. So the product of this, the product is going to be hydrogen plus sodium chloride. This is not how your product will look like. This carbonic acid, usually it doesn't stay like this unless it's under a very high pressure. Carbonic acid, which is H2CO3. Now, because if it's not under high pressure, it will decompose back into H2O and what? CO2. Right? Now, our final product is going to be, let me rewrite the whole thing. Sodium carbonate plus HCl. Then our product is going to be what? Sodium chloride plus H2O plus CO2. So this is our final product. So you go ahead and balance it if it's not balanced. Let's say we have calcium hydroxide. Then we have heat. How do you predict the product of this particular reaction? Now you know that whenever you heat a hydroxide, you are going to cause water to evaporate, and once water is removed, what you get to become metal oxide. So in this case, we have water evaporating, and then what is left will now be what? To evaporate as a gas. So what will be left to now be what? The metal hydroxide. In this case is what? Carbon oxide, calcium oxide. Now let's put another one. Let's say we have aluminium. Aluminium. We have heat. Since you are heating it again, the same process, water will be removed in form of gas, and then what will be left will be what? Aluminium. But then we'll still take the same process. We have aluminium, right? And then we have OH. We still do the same process. Aluminium, so this will not be OH, this will be oxygen. Aluminium and oxygen, right? We want to just get the accurate product here. I don't want to just go ahead and give us a product so that you will have a better understanding. We know aluminium is what? +3. And then oxygen is -2, right? So you cross it. So what we'll now have here is going to be what? Aluminium 3, and then aluminium 2, oxygen what? 3. Oxygen will carry base 3, aluminium will carry base 2. So therefore here we're going to have aluminium base 2 and oxygen base 3. So you go ahead and balance the equation if it's not balanced. This will be all for this video. Please like, share, and subscribe. And when you subscribe, please don't forget to hit the notification bell so that you'll be notified once we drop another video. And please drop your comment at the comment section below. Thank you for watching.